Welcome to Eureka Math. I'm Mr. Schenkel. I have Module 1, Topic D, Review 2 answers for you. And let's get started. So number 1, we're looking for the recurrence relationship for this sequence. And we have to write the recursive relationship in equation form for what's happening to these numbers in the sequence. So it's going to start with this. We're going to say going to say a sub I plus 1. So our last result plus 1, which is our next result. Our next result is equal to, well, what is happening to our initial values? Well, if we looked at the 3 to the 9, 3 times 3 is 9, and then 9 times 3 is 27, and 27 times 3 is 81. Looks like we're just multiplying the initial value times 3, so that is our equation. It's just 3 times a sub I. All right, and then we also might say that in this sequence, our initial value, so the value after round 1, is 3. And then we could go from there, right? If we said a sub 1 plus 1 is equal to 3 times our previous result was a 3, so 3 times 3, then we would have a sub 2 is equal to 3 times 3, which is 9, and that gets us our next sequence, and away we go. Next value in the sequence. Number 2, same thing. A sub I plus 1 is equal to, well, what is happening to our initial value? Well, it looks like we're taking 5 away every time, so that's just our initial value, A sub I, minus 5. That's it. And we would say, well, our initial value after the first round is an 8. So our initial value is an 8, and if we wanted to just make sure, I guess, that our equation works, then I could just plug in a sub 1 plus 1 is equal to, well, a sub 1 was an 8 minus 5. And then we could simplify that and say, well, a sub 1 plus 1 is a sub 2, or the result after our second round, is equal to, well, 8 minus 5 is 3, and that is what our second value is. So we got it. That's it. Okay, so this is what we're looking for right here. No, letter C. What's happening here? Well, it looks like, what is this? That's a plus 4. This is a plus 8. This is a plus 16. I don't know. Are we doubling? Maybe we're doubling. And if I double it, if I double 1, well, 1 times 2 is 3, but I want it to be 5, so I could add 2 to that to get 5. And that worked. Let's see if I do that with my next term. 5 times 2, well, that's 10. And then if I add 2, or if I add 3 to that, I get 13. So it looks like we're doubling and adding 3. So here's my recursive relationship. A sub I plus 1 is equal to, well, I'm doubling, so 2 times A sub I, and then I'm adding 3. And what's our first value? Well, it's a sub 1 is a 1. Well, let's see if that makes this true. A sub 1 plus 1 is equal to 2 times a sub 1, which is a 1, and then plus 3. And let's see if that's what we get. Well, a sub 1 plus 1 is a sub 2, so the result after round 2. Hopefully it's a 5. Let's see. 2 times 1 is 2, and 2 plus 3 is 5. Yeah, it is. So this is going to work, and that is our recursive relationship. All right. Number 2, the formula a sub n equals 2 times 2 to the n minus 1 power times the quantity a sub 0 plus 5, and then minus 5 describes the nth term of the double and add 5 game. Where a sub 0 is the starting number and n is the number of terms, the number of rounds. Use this formula to find the smallest starting whole number for the double and add 5 game that produces a result of 5,000 or greater. Well, the 8 rounds is going to be my n value. 8 is my n value. So that means that a sub n would be a sub 8, the result after round 8, is equal to 2 times n, well, that's an 8, minus 1. 8 minus 1, we'll simplify that later, times the quantity, a sub 0, plus 5, and then minus 5. And then all of that has to be 5,000 or greater. That's greater than or equal to 5,000. Okay, let's simplify. I don't really need this part anymore because it's just going to tell me what I'm finding is the result after round 8. But my inequality is what's left here. So let's just solve this. Well, this would be 2 to the 7th power. 8 minus 1 is 7. And then we're going to distribute that. So 2 to the 7th power times a to the 0 is 2 to the 7th a sub 0 plus 2 to the 7th times 5. Well, I guess let's find out what 2 to the 7th is. 2 raised to the 7th power, 2 raised to the 7th power is 128. So I'll fix this. Let me just change this. That's going to be a 128, a sub 0. And then 128 times 5, 128 times 5 is 640, so plus 640. And then minus 5 is greater than or equal to 5,000. Now let's see, I can add these together. I got 128a sub 0 plus 635, if I combine the 640 and the negative 5, is greater than or equal to 5,000. And then just isolate a sub 0 because that will be my initial value. So I'm going to just subtract 635, subtract 635. That gives me 128a sub 0 is greater than or equal to, well, 5,000 minus 635 is 4,365. And then just divide by 128. And that's going to leave us a sub 0, which is what we want, has to be greater than or equal to 4,365 divided by 128, which is 34.1, approximately. And the first whole number greater than 34.1 is, of course, 35. So the smallest number where we would get 5,000 or greater after 8 rounds, the smallest starting number would be a 35. All right, that's number 2. Number 3, last one is the tax problem. Let's see if we can work on this. I can explain this for you, and then you just follow this when you see it again on the test. A famous movie actress made $10 million last year. She's married and has no children, and her husband does not earn any income. Assume that she computes her tax income using the following formula. Okay, the taxable income is something that we need. Let me pop over here. We need the taxable income so we can figure out how much tax you owe, and it comes from this table. So we have to find the taxable income before we can figure out how much tax you owe. So the taxable income is the amount of money that you make minus any exemptions and deductions. So we're going to first calculate that, and that's going to be, well, my taxable income. I'm going to call that I'll call that T, taxable income. So I'm going to say my taxable income is equal to my income, which is 10 million. I kind of like saying my income is 10 million. That sounds good. Not going to happen, but sounds good. Taxable income, the total income is 10 million, and then we're going to take away exemptions. So the first exemption is, remember, she is married, no kids. So let's go to our first table, and we're looking for married right here, no kids. The first deduction is $7,800. So I'm going to back up, and I'm going to take away $7,800. That's the exemptions. Then I need to take away the standard deduction. Well, let's pop back over to our table. Standard deduction for married and filing jointly is $12,200 right there. So I'm going to subtract that away, minus $12,200. And when I do all of this subtraction, it's going to give me the taxable income. So taxable income is 10 million, let's go 10, 0, 0, 0, 0, 0, 0, 0, 10 million minus 7,800 and then minus 12,200, and we get 9,980,000, and that's it. Taxable income. Now, this determines where we go to find how much taxes are paid. All right, so we're going to pop over to our table, and we're going to look for the income bracket that's 9,948,000. Well, it's the last one. This actress has topped out. So she's in the highest tax bracket. And the first thing we see is this is a tax that she's going to have to pay, $125,846. Plus anything above $450,000, she has to pay an extra 39.6%. So we want to make that happen in our equation. So I'm going to go back 125,846. Let's see. So let me put it down here. 125,846. 125,846. I'm definitely paying that. And then we're going to add to that the percentage. Remember, the percentage was 39.6%, and I have to write that as a decimal. So 0.396 times whatever is over 450,000. So my taxable income is 9,980,000. And I'm going to pay extra tax on anything over 450,000. So I need to subtract the 450,000 because I've already accounted for that tax over here. And when I add these together, that's going to be the amount of tax that I'll pay on this income. Okay, so what do we have? Well, I need to simplify my parentheses here. So 9,980,000 minus 450,000 is 9,530,000. So this is 9,530,000. And that's the amount I have to pay 0.396, 39.6% of, is also going to be taxes. So this part is my additional taxes, plus the amount of taxes I paid on the first 450,000 was 125,846. So now I need to know what is 39.6% of 9,530,000. So I'm going to multiply 9,530,000 times 0.396, and that gives me $3,773,880 I'm going to pay, plus this $125,846. And when I add those together, I'm going to add that $125,846. When I add those together, I get a total tax bill of $3,773,880. $899,726 that this actress is going to pay in taxes. Those are dollars sent to the government. Now, what we're looking for now is her effective federal income tax rate, which means what percentage of her money, the $10 million, is she paying to the government? Well, that's just the amount she pays to the government divided by her money, which was $10 million. And when we do that, we will get a decimal that we can change to a percent. So 3,899,726 divided by 10 million is equal to 0.3897. I could keep going. We'll round it off at about, which is approximately 39% of her money goes to the government. She gets to keep 61% of the money she earns. She has to give the rest of it to the government. It's a lot of money. It's a lot of money. All right. And that is it, I believe. Yes, that is it. That's the second review. All of those between the first review and the second review will be test type questions. If you can do those, you'll be in good shape. Hope that helps. See you again next time.